Greetings and welcome back. In the last video, we created a basic sprite emitter, which you can see here, that just puts some multicolored sparks into the scene. Now we're going to create a GPU sprite emitter. And to save us a little bit of time, what we're going to do is start by converting this into a GPU emitter and show you why that's a good thing to do and some of the considerations. I won't call them pitfalls, but some things to keep in mind when working with GPU sprites. So for starters, let's create a new folder inside of our My Particle Systems folder. So I'll just, over here, we'll go to new folder and we'll call this GPU Sprite, and that'll work. Let's open up the Sprite folder first, and I'll take that same particle system, the one p-sparks we created in the last video, I'll drag that into the GPU Sprite folder, and we will copy that. So we have our own custom version of it that we can adjust. Let's go ahead and rename this so we can keep track later, and we'll call this p-sparks underscore GPU. Okay, now here's why we want to do that. First off, here's our little GPU sprite area. Let's just drag our emitter in right here. And obviously at the moment this is the same thing. What happens if we want this to have a whole lot more sparks than it does right now? Well, if we open up the template or the particle system here in Cascade, if we were to currently take the number of sparks and really crank it up, let's say from 50 to, oh, I don't know, let's do something really silly like 500. We get a whole lot of sparks, which of course is great. And you can see it's certainly trying to kick those out for us, and the color's getting super intense because of that, which is awesome. We'll probably tweak the colors to make up for the sheer volume that we have. But what if we want to go higher than that? Let's say we want to do like 2,000. Well, we quickly run into a problem, and it's right here inside the particle count. Now, you might not be able to see the particle count too well right now because it's blue on black. We can change that. If you click on this tiny little color bar up here for this emitter, it's right here on the left-hand side, we can change that to something a bit more visible. So I'll change it to yellow. So you'll notice right now I've got a 1,000 particle cap on this emitter. Now, if I needed to change that for some reason, I could. But I don't really want to. If I go into the required module, actually, there is a max draw count that I can change, and I can start working with that. But really, this is basically the system saying, hey, that's too many particles for a CPU emitter. So at this point, we want to convert it over to a GPU emitter. That's easily done. We just right-click here at this little blank spot in the emitter list, and we can say type data and add a GPU sprite type data module. Now, there's a problem with doing this. Actually, there's a few problems. Let's make Cascade nice and big. The first and foremost is that we don't see anything, and we get these big, nasty red X's on a couple of our modules. Not every module available in Cascade will work with GPU particle systems. It's a trade-off. You get more particles, but you get fewer features. Now, it doesn't really matter. You also get some new features that aren't available anywhere else. So, like all things in life, it's a trade-off. We're going to take the collision module and we'll get rid of it, take a light module, delete that as well. And now suddenly everything just starts working. And over in our level, this is working too. In fact, it's working a little bit too well. So let's change the color a little bit to make that a little less assaulting on the old eyeballs. Let's say we take the color at birth. Let's do something in the green spectrum this time. So 0 and 7, and not 0, leave it at 1. That way you start to push toward white, which is a lot more realistic. And actually, let's set this one to a constant. Let's say I don't want this one to change color. We can take that distribution, which right now is set to a curve, and we can just set that to a constant value, and that means that these particles will always have the same color. So we will make that what? 1 for red, let's say 10 for green, and maybe 1 for blue. We get a nice, brilliant emerald green. Even 10 might be a little high. Let's try pulling that down to about 5. Also, it's a good idea to double check this. Make sure that your exposure controls are working or off. So turning them off will often make things like this look a little better because your eye your virtual eye in terms of the game will quit adjusting with you, and that can really help with your effects. It's good to test in both directions, but for now I think we're going to turn that off. So here we go. So 1, 10, and 1, and there we go. So now we're pouring a whole bunch of greenness into the scene. I'm gonna do a couple of things. We're gonna get rid of our initial location. So now we're just pumping out from a singular point. I like that a little bit better. Now we're also no longer colliding the way we were before. If we get down underneath, oh, no, did you see that? The creepiest thing just happened. Watch this. Right as we start to rotate out of the view, see what's happening? Our particles disappear. And this allows me to talk about that other problem that we saw a little while ago. So we cleaned up our extra modules, but we're getting this warning. This particle system has no fixed bounding box and contains a GPU emitter. That's a problem, and it may not be readily apparent why until you rotate the camera away. As soon as the emitter leaves the view frustum, this particle system will stop rendering. That is the nature of GPU particles. So what's the solution? The solution is to create a fixed bounds or an area around this particle system where we say, all right, the bounds are in view, so you can go ahead and calculate the particle system. It's easily done. All we do is we can show the bounds if we want to see them, and then we click on the little drop-down arrow here and we say set fixed bounds. Now once we've done that, if you immediately test in the view, it's still going to blink at you. Make sure that here in Cascade you click restart level, and now, check it out, we can rotate completely out of the view and the particles remain. That's because as long as that bounding box, which we can now see here inside of Cascade because we've turned on bounds, as long as that remains in the view frustum or what the camera can see, then these will continue to evaluate. So definitely worth being aware of. Okay, so the next thing I want to do is deal with collision, because if I come out of the view, you'll notice these are just kind of falling down through the floor. Collision with GPU particles is really easy to set up. We just right click and go to collision, and there's scene depth. This is actually using the depth buffer off the graphics card, and boom, we get bouncing particles. So let's take that collision module, excuse me, and we're going to take the resilience, which is how bouncy these are. We're going to pull it really far down, like 0.1. And friction will be 0, so these will just hit and they'll kind of slide a little bit. Excuse me. So now if we take the lifetime, let's kick lifetime up to about 1.5 seconds. So now you can see they kind of start to slide like some sort of fluid across the surface. If I give a little bit of resilience back into that, maybe 0.3, they'll get a little bit of a bounce and then they'll slide some more. Now the neat thing about using the depth buffer for this sort of thing is that any objects that we want to collide with this basically just work for free. So if I have, let's say a chair, right? I'm just pulling a random static mesh of a chair. Watch this. As I slide it through the particles, they just bounce off of it. You just get that. So definitely cool and definitely fun to play with. Now there's another feature that GPU particles can do that nothing else can do that is definitely worth checking out, and that is vector fields. Now vector fields are a three-dimensional representation of vectors that you can use to push particles around within the space of the vector field, within that volume. Now currently we are here at Epic, we are creating vector fields by taking a fluid simulation from Maya and taking a single snapshot of that fluid simulation in time, storing the vector data, basically how that fluid was moving at that moment in time, and saving that out. There is well, we're using some of our own tools for that. And I don't want to remark as to whether or not those tools are available right now to everybody. They may or may not be, but you do have access to a couple of vector fields if you want to play with them. There are some already in the Elemental project, which I know we released, so you can play with those. When the Elemental dude stands up, you know, the big lava knight dude, his eyes spit out some particles that swirl around in a really interesting way, and that's because of a vector field. So you can actually get into that project, you can dig out those vector fields. However, I am in the Content Examples project, and if you take your filters, which I'm going to reset real quick, if you go into your filters in the content browser and you go under miscellaneous and go under vector field, there's a couple that are included here. So I'm going to take the Vel 219, which is apparently the frame number that Maya was on when it stored that out. And let's use that. So I'm going to first right click, and we'll add a vector field to this, and it'll be a local vector field, meaning it is a part of this particle system. And in the properties for that, it's going to ask for what vector field you want to use. I can just drag and drop this right inside here. Now, a couple of things. First off, you may not be able to see your vector field at first. Let me turn our bounds off so they're not quite as distracting. If you look under View, you should see vector field as an option, so you can turn that on and off. Now currently that vector field is pretty small, so let's change the size of this. Let's do a relative scale 3D of something like 20 by 20, not by 2, by 20 by 20, so 20 in all three axes. And you can move the field around relative to the location of the emitter. Now currently it doesn't look like it's doing much, and that's only because it's not. If I take this vector field, I can kick up its intensity, which is how much those vectors are going to push the particles around. And then we have tightness. This is how much influence the vector field is going to have. 0 being no influence, 0.5 meaning it's just kind of starting to push the particles around a bit, and then 1 being it's totally taking over control of where the particles are going. So they're only going to go where the vector field tells them to go. So if I position this the right way, and then maybe take my lifetime and let's kick it up to, oh, I don't know, let's say 5 to 7 seconds. So they have a lot longer to live. And now they're starting to kind of move through the scene a little bit. I'm going to take their size by speed and we're going to pull that down. Let's go to about 3 by 3. There we go. And that gets rid of some of that flicker. They were just stretching out a little bit too much. Also take my vector field and we can just kick that intensity way up. There you go. And now it's starting to whip these guys around into sort of this spirally line. Notice as soon as they leave the bounds of the vector field, they just kind of fall off. The acceleration kicks them up and they just drop. So let's take our vector field and I'll make it bigger. Let's do 30 by 30 by 30. So now we're getting sort of a really cool spirally effect. Still, when we leave the bounds, we just kind of fall down. That's okay. Let's make things a little more interesting. Let's take our vector field and spin it around. If you take a look at vector field, you have vector field rotation rate. We can add that, and then we can just determine how fast we want the vector field to spin around on all three axes. Let's do like 0.1, 0.15, and, oh, I don't know, 0.07. Now we're spinning on all three axes. So let's take a look and see what that looks like in the level. And it's just really spinning those around and doing really cool, interesting swirly designs. Now we can start to kind of customize that a little bit. So if we take our tightness and pull that down to about 0.4, so we're only influencing the particles a little bit. Now they're just going to splash around a lot on their own. Let's maybe pull the particle system back a little bit, kind of toward the center of our little area here. Also, probably a good idea to reset our fixed bounds because they're obviously a lot bigger. Our particles are moving in a lot more different, crazy directions at this point. So there you go. There's some GPU particles doing just some really wow madness stuff, and definitely play with that and you can get all kinds of really wicked and neat effects. What I'm going to do is pull my intensity down to about, I don't know, let's say 80, tightness down to about 0.2, and let's see what that starts to do. Now, I like the higher intensity, so let's push that back up to about 100. Oh yeah. So it's almost like some strange, spooky, scary, fluidic effect. And it still has the collision, which is a really awesome touch. Okay, so we've now created a GPU sprite emitter. We've noticed a few important things. One, a GPU system will not draw if it doesn't have, if the emitter is not in the screen and it doesn't have a fixed set of bounds. So make sure you always, always, always use some fixed bounds when you use it, when you create a GPU emitter. Also, on that note, and I should point this out, on the required module, is it on, or I'm sorry, it might be on the entire particle system. Yeah, so if you click on the empty space here on outside your emitters, you'll notice there's a bounds group. and there's your fixed relative bounding box. So if you need to change that, so earlier we just clicked on this little button and told it to fix the bounds on its own, but if you want to modify that on your own and make some changes, here's where you do it. You can set the min and max sizes for those bounds. So if you show those first, then you can just tweak them here and make your bounds bigger or smaller. So that's how that works. Okay, some other things we noticed that were super important. Not every module you might have added to a particle system is going to be compatible with GPU sprites, but at the same time, you get some benefits that aren't compatible with anything else either. Like vector fields don't work with CPU particles. It's just a GPU particle only thing. This collision via scene depth, also only on GPU particles. So it's a trade-off. You lose some things, you gain some other things. GPU particles cannot emit light because there's no location that is handed back off to the CPU for the light to follow, so you just don't get that. If you wanted this particle system to look like it was emitting light, you would need to create another emitter that was here inside your particle system that maybe rendered out invisible particles that just had a light module. So you would you'd have some particles that you wouldn't actually see the sprite itself. You would only see the results of a light module. So essentially, you'd fake it. So that's going to wrap things up for this video. Thank you very much.